Assalamualaikum and hi. Today, our group, which is group 11, will be present about air conditioning for engineering thermodynamics laboratory. Our group consists of 4 people, which is NAVEN, AHMAD, Tineswar, and also me, NURFAZRIN, NABILA. Introduction. Air conditioning system. Air conditioning system known as electrical device that install and function to remove heat and moisture in occupied space in order to obtain comfortable environment. Refrigeration cycle. It was a thermodynamic cycle that mainly functioned to remove the heat from the surrounding space and cool the space around it. The cycle is operating in closed-loop system, which is one-way system. The air conditioning system actually used the refrigeration cycle in order to complete the process, as both of them has the same main objective, which is to remove the heat and cool the surround space. Objective of our lab. First one, to evaluate experiment the performance of refrigeration system of the air conditioning unit model AC01. Second, to compare the performance of refrigeration system to theoretical value. The theory of our lab is there are several gas laws that combine together in the air conditioning system, which is become combined gas law that consists of Boyle's law, Charles' law, Gay-Lucas law. In the combination law is that if the heat increase, thus the pressure will increase too. The diagram show the air conditioning cycle for our lab. The apparatus and setup. We have 15 apparatus and the setup figure shown in the slide, which is the first one is control panel, the second one is expansion valve, the third one is orifice, the fourth one is DP transmitter, the fifth one is heater, 6 is pressure switch, 7 is refrigerant condenser, 8 refrigerant compressor, 9 refrigerant flow transmitter, 10 humidity or temperature sensor, 11 fan, 12 humidifier, 13 side glass, 14 refrigerant pressure transmitter, and 15 filter dryer. The procedure. Before we start our experiment, we actually need to do the general startup procedure, which is we have 5 steps in total. The first one, the model inspect to ensure it was proper operating condition. The second one is the humidifier water supply is connected to the tap water source. The third one is the drain hose connected to the condense collector at the bottom of air duct. The fourth one is power supply will switch on. And lastly, make sure the main power switch on for the air. The procedure of our experiment is switch on the radial fan and run air velocity at 15% in maximum airspeed. Then refrigeration unit was switched on. Let the system for 15 minutes in order to make it reach the steady state. For temperature 1, temperature 2, 4, and PT1 and PT2 of the refrigerant circuit were recorded in table of data. Lastly, the refrigerant flow rate FT1 from the refrigerant flow meter were obtained through the experiment. Lastly, before we finish our experiment, we have general shutdown procedure. First, we need to preheat the switch off and reheat to allow the heater to cool down by the fan on. Then, the fan speed control knob turned off, then the fan switch. Third is ensure all other switch on the control panel will switch off. Fourth, switch off the main switch and power supply. And lastly, the tap water supply will switch off.
Hello and good day to doctor and everyone. My name is Tineswar, son of Jaganathapillai. My metric number is MA19217 and I'm here to present about my part in the air conditioning lab report, which is the results and data calculations. Let's see the table we completed through the lab report. The temperature from 0.1 and until 0.4 and also refrigerant pressure from 0.1 to 0.4 were collected from the experiment. By using the collected values from the experiment, we need to find the following parameters according to the report. Okay, we see the refrigerant flow rate. Refrigerant flow rate was also given and collected from the experiment, and followed by the refrigerant enthalpy point from H1 to H4 we need to find. Point 1 and by referring to the schematic diagram or TS diagram of the air conditioning system, point 1 and point 2 is saturated vapor zone, and point 3 and point 4 which is a saturated liquid zone. So in order to find the enthalpy at 4 points, we need to refer the table A11 in the property table to find the values. Since the values are not in the table, so we need to do interpolation method to find out the enthalpy at each points. Then After completed the enthalpy at 4 points, we need to find the refrigerant mass flow rate by using the formula, which is the refrigerant flow rate is Mr Ft1, which is the specific volume, divided by V times 60 times 1000, which we will get 0.53, and followed by lastly the refrigerant output, which is referred by QR, which we will get 83.05 according to our calculation. Next, we see the next part of our calculation, which is the compressor performance and output of the air conditioning system. These are the calculated values by using the parameters with the use of appropriate formula for the given parameters. First, we need to find the actual compressor work, which is represented by WA. By using the WA equals to H2 minus H1, we will get the value, which is 330.91, and then followed by the actual coefficient of performance, which is represented by EA. EA also we need to replace the values into the formula in order to find out the value, which is 5.032, and then followed by the theoretical compressor work W, which is represented by WT. WT is H2 minus H1, which you will get 21.12. After that, theoretical, we need to find the theoretical coefficient performance and also effective power factor, which will also need to replace the following values into the formula in order to find out the value. In order to find out the effective power factor, we will need also to replace the mechanical efficiency of the compressor, which is 0.8 according to the report. Then we need to find the theoretical compressor output, which is represented by PT. PT equals to MR times W1. We will get 7.19, and then the last two parameters is the internal combustion output, and which is represented by PA, and compressor drive coupling power PK, which is 60.38 kilowatt and also 20.47 kilowatt respectively. These are the calculated values by using the given parameters with the use of appropriate formula for the given parameters. That's all for the results and data analysis for our lab report. Thank you.
Good day, doctor. So myself, Navin SANKRAN, and my metric number is ME199275. So today I'd like to explain about the discussion. The first question is about working principles of condenser, compressor, expansion valve, and evaporator. This is condenser. So basically, the condenser is a process of converting gas into liquid. So the primary goal is to liquefy the refrigerant gas drawn from the evaporator by the compressor. Only if the condensation temperature is higher than ambient temperature, will heat flow from the condenser into the air. And next will be the compressor. Compressor job is to draw the low temperature, low pressure vapor from the evaporator through the suction time. And once the vapor has been drawn, it will be compressed, causing the temperature of the vapor to rise. In other words, the principal function to boost the pressure by converting a low temperature vapor, to a high temperature vapor. And the compressor discharges the vapor into the discharge pipe. So next will be the expansion valve. Expansion valve is it is frequently situated from before the evaporator and at the end of the liquid line. So the liquid refrigerant reaches the expansion valve after it has been condensed. So the temperature of the refrigerant will drop to a level below that of the atmosphere when the pressure of the refrigerant is reduced. After that, the liquid will be fed into the evaporator. So next we'll like to explain about the evaporator. So the evaporator transport heat from the chill environment to the heat pump via a liquid refrigerant. So liquid refrigerant should be lower than the product to be cooled in order to achieve the heat transfer. An evaporator is a device that converts a liquid into the gas. So second discussion question is about the pH and pH diagram of the refrigerant cycle. First is a theoretical diagram and then is the actual. So first theoretical, we can see the first diagram is the pH diagram. So pressure and then the enthalpy is the H. So this is the pH diagram, which is the curve, and this is the saturated liquid line, and then next is the dot will be the critical point, and then on my right region will be like superheated region, And the second theoretical diagram is TS diagram. TS diagram is, as we know, the ideal refrigerant cycle TS diagram. This is the TS diagram. First, the upper part is will be a subcooled region, and then the right region will be a superheated. As we know, the critical point, and then as I shown, wrote the wet region, and then the line will be like the saturated vapor line. I mean water line, and the end part will be the saturated vapor. So below will be the actual TS diagram and pH diagram of this refrigerant cycle. So this is first is the pH diagram. The top pressure will be 7.2 bar, and then the lowest will be the 1.4 bar, and the below part will be the calculated enthalpy values. Next is the TS diagram. TS diagram will be for several temperatures, which is the top temperature will be the 50.1 as we collected data, and 26.7 Celsius, 25.9 Celsius, and the starting point will be like negative 10.2 Celsius, and the below axis will be like the entropy, which is the and S will be calculated. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad JAMLI and MA1N036, and I will be presenting on discussion for question 3 and question 5. So for question 3, from the TS and pH diagram, discuss the performance of the refrigeration cycle. So from the refrigeration cycle for corresponding enthalpy values, from the table refrigeration cycle, so for H1, for state 1, we get enthalpy for 244.38 kilojoule per kilogram, and H2 we get 275.29 kilojoule per kilogram. For state 3, which is H3, we get 88.83 kilojoule per kilogram, and for our state 4, which is H4, is we get 87.68 kJ per kilogram. Question number 2, COP values of the experimental and theoretical result. Explain the difference. So the obtained value coefficient of refrigerant performance between experiment result and theoretical is 5.032 and 155.55 respectively. It can be concluded that the experiment result value is much lower than the theoretical result. The reason behind it is the theoretical value is what one estimates based on the existing theory that allows for detailed predictions. The experimental value with an error is a result to obtain from the collected data that will enable one to get by state-of-art analysis a numerical value of quantity of interest. So when an experiment is confronted with a theory, it is determined that whether it is valid within bounds set by the experimental error and the uncertainty of the theoretical prediction. So for question number 3, explain the difference between vapor compression and absorption cycle. The refrigerant is compressed in a vapor compression refrigeration system using a compressor, which can be reciprocating, rotational, or centrifugal. Refrigerant is compressed in a vapor absorption refrigeration system by the absorbent absorbing the refrigerant. As the refrigerant is absorbed, it is transformed from a vapor to a liquid, resulting in a reduction in volume. The functioning of the vapor compression cycle's compressor will produce a huge amount of electricity, which rises as the size of the refrigeration system grows. The pump in vapor absorption refrigeration system use a very little power, and it stays almost the same or slightly increases even when the refrigeration capacity is increased. As a result, the vapor absorption refrigeration system consumes significantly more energy than the vapor compression system. The vapor absorption system is primarily driven by the plant's waste of excess heat. As a result, the boiler's extra steam may be utilized, or more moisture can be created and combined with the available hot water. Waste heat from the diesel engine as well as hot water from a solar water heater may be utilized in the same way. In a vapor compression refrigeration system, the compressor can only be driven by electricity. No other energy sources can be utilized. In the vapor compression cycle, the compressor regulates the system capacity, and in most circumstances, stepwise capacity control is achieved. When utilizing an absorption refrigeration system, stepless capacity management and zero capacity may be achieved when the system is not loaded. Even though stepless capacity control compressors are now available, they waste a significant amount of energy even when the refrigeration system is not in operation. So, the power consumption of an absorption system is almost non-existent when there is no load. What happens to the COP of refrigeration system if the temperature of the refrigerant coming out of the compressor decreases? Explain. So, the heat extracted from the cold reservoir, Q cold, divided by the work done to remove the heat is the coefficient of performance, or COP, which is of a refrigerator. So, we can see for the formula is COP is equal to Q cold divided by W. So, as can be observed, the more heat Q cold that can be evacuated from the inside of the refrigerator for a certain amount of effort, the better and more efficient the refrigerator is. So we may rewrite the preceding equation as follows: Q cold plus W is equal to Q hot, since the first law of thermodynamics must be valid in this situation. So Q cold plus W is Q hot, so we can rewrite it as follows: COP is equal to Q cold divided by W, so equal to Q cold is divided by Q hot minus Q cold. So for an ideal refrigerator without losses or irreversibilities, can be derived that COP is equal to T hot divided by T hot minus T cold. So these formulas are also used to create an air conditioner that functions similarly to a refrigerator. So the COPs for heating and cooling on the other hand are not the same. Refrigeration system coefficient of performance will grow when the compressor's refrigerant temperature provides an enhanced value. The above mentioned formula is the rationale for the specific set of circumstances. The coefficient of performance COP is the ratio of heat eliminated at low temperatures to work done in the system. Generating fluid is a material that can quickly transition from gas to liquid and back across a wide temperature and pressure range. The compressor, condenser and evaporator, the three basic components of an air conditioner, circulate this refrigerant continually. So as for conclusion, we were able to perform our experiment digitally. An air conditioning laboratory unit was used to research the air conditioning process, which entails maintaining a desired temperature and humidity in a living area or institution. So regardless of the exterior climate circumstances, the experimental findings show that air may be conditioned to desired levels to maintain the health and comfort of occupants or to meet the requirements of industrial processes. So we look at lab experiment that demonstrate the basic thermodynamic cycle present in air conditioners. We obtain temperature and pressure readings at each point of the cycle from the lecturer in charge, as well as the power draw from the compressor, and we will analyze the data to develop a better understanding of how performance and electricity costs affect this device. So that's all from me. Thank you.